Welcome to lesson 3.2, where we are going to talk about the remainder theorem. So, remainder theorem has two main purposes. First is synthetic substitution, and the second is finding factors. Now, let's talk about the first one, synthetic substitution. It's kind of a weird word, but we'll talk about it as we go. Let's start by a quick review. If we look at this first problem, it says evaluate p of x equals x squared minus 4x plus 7 when x equals 5. So that means I want to plug 5 in for every x in my equation. Using function notation, essentially we're saying we want p of 5, which just says plug 5 in for every x. Now, I can use a calculator to simplify this. 5 squared is 25, 4 times 5 is 20, and so I get that p of 5 equals 12. So this was using function notation, something you've probably been doing since junior high. We can actually use synthetic division to do the same thing. So synthetic division, that's what we talked about last time. It's really cool because it's a second, completely different way of finding the same answer. So right here, this is what we just did, p of 5, and we got 12. Well, you can do synthetic division, put 5 into your box, write out your coefficients, bring your first one down, multiply, put it in the next column, add, multiply, put it in the next column, add, and your remainder, your last number right here, the remainder, is actually the same answer that you would get if you just plugged it in and simplified, which is kind of cool. It's just two very different ways of getting the same answer. So let's practice that right here. Use synthetic substitution, which is meaning use synthetic division to find our answer, our substitution answer. So what you're going to do is whatever you're plugging in, that becomes your box number. And now we do synthetic division like we did last class. So we list our coefficients first, -2, +3. Oh, but wait. Looks like I have a placeholder right here because I'm missing an x cubed term. So I have a placeholder of 0 x cubed because I think that descending order, x to the 4th, x cubed, x squared, x, no x's. Now we're good. Next is that +3. Then I have -15. And finally, +9. Okay, now I do my synthetic division, bring down the very first one, and then do my pattern. So I'm going to take that number times the box number, -2 times -3 is a +6, put it in the next column. Add that column, 0 plus 6 is 6. Repeat it because I have more columns. So that number times the box number, 6 times -3 is -18. Add it, 3 minus 18 is -15. I have more columns, so repeat it again. -15 times -3 is a +45. Add my column, gives me 30. And I still have more columns, so repeat it again. -3 times +30 is a -90, which then I add down the column to get a -81. So we did all that because that should be the answer when we plug -3 in. So if I plug -3 into this equation, I should get -81. Now, for this problem, let's verify that. So f of -3 should be -2 times -3 to the 4th plus 3 times negative 3 squared minus 15 times negative 3 plus 9. Now, you can type all that into your calculator. Be careful with your parentheses. Make sure you follow your parentheses. And when you type that in and simplify it, you get negative 81. Same thing. So, just showing that we have two very different ways to get the same answer. You can plug it in, or you can use this synthetic substitution. So that's our first video on synthetic substitution. In the next video, we'll talk about another application of the remainder theorem, which you can probably get how it got its name now, is your remainder, is your answer. And we'll talk about the second application of the remainder theorem, which is finding factors.